When the travel was first conceived, it was a really kind of a luxury experience. And the design of architecture really followed on that ideas. There was a lot of anticipation and excitement happening at the same time. And the airport was even a space for spontaneity to happen. Can we say the same thing today? What kind of travel experience are we exposed to? And what kind of what kind of exposure do we have as our bodies moving through space? We crowd and line up, wait for our turn. Here we line up. We get to strip, be examined, checked, screened, searched, sorted, documented, stamped, and finally shipped. It's a pretty similar experience to what our luggage is going through, or the experience similar to the industrial process, assembly line, or the way Amazon Fulfillment Center is operating. Airport architecture is often seen as this large container that does not respond or even ignores a human body and human experience. So we are left to our own devices and have to find a way to have our body adapt to the surrounding or improvise. I'm going to show 3 case studies, 3 different scales and 3 different approaches that in my view could address the problem of the human body in space and human experience at the airport. First, I'd like to talk about just one system out of many different systems in a large building such as airport, a suspended ceiling, and how the design can contribute to a different experience. In 1962, Renan Benham called the suspended ceiling an utopian or a Dymaxion dream. He maintained that a suspended ceiling could far surpass the limitation and functions of the exterior paneling or curtain wall system. But today, 5.5 decades later, the suspended ceiling has continued to be unseen, invisible, or indifferent element of architecture, and its design has almost completely remained unchanged or unchallenged. Suspended ceiling system has been so standardized by its grids, parts, electrical, light, and ventilation, and confined by the code that it's very difficult to integrate anything new to it. So we decided to challenge that notion and work still with what's given by the industry, the aluminum T-bar. But instead of laying it out in an orthogonal manner, we twisted the grid and added a diagonal member, creating a new grid of isoscale triangles. The new grid forms an organizing system that determines all the spaces within this dental office that I'm showing you here that we designed, and the ceiling grid is then infilled with nearly 400 vacuum-formed acrylic panels. The idea came to us by realizing that when you sit at the dentist chair, all you stare at is the ceiling, yet the exam room ceilings are rarely explored. And here's the view of what you see from a dental chair. So we spent some time designing the typical unit and its variations. The panels consist of 4 unique types, all made from a combination of 0 to 3 pyramids, which with possibility of being placed facing up and down, create about 8 different conditions. This is how they come together. And we also started explorations of mass productions with the use of vacuum forming. We tested positive and negative molds, first trying the foam and seeing our molds, and then adding the polystyrene layer as a protector before we could vacuum form the final units. Both exploration ended up as failure, as we realized our molds won't last the production of 400 units. So then we moved to wood and laminated the pyramids out of MDF and then again CNC the pieces, and ran the final cut and then manually sanded them. Here they are, the 4 units that then that became our molds for fabrications, and we made a list of what we needed and count all variations and possibilities. We added also flat units to allow for the contractor to trim on site, and they were all brought to the fabricator that later, you can see them in the back, started vacuum forming it. And after testing multiple different plastics, we went with this 40% translucent acrylic. The fluorescent lighting was installed behind the ceiling panels and spread evenly throughout the space, so we could achieve a uniform glow. And this is the map of all different units and their location, more like a puzzle. For panels that accommodated HVAC, we had to design a special transition unit that we designed that connect the circular ducts above the ceiling with the triangular openings of the acrylic panels. And the little openings were cut to allow for the air to flow. Here it is seen from below. So when you look at this space, this is what it looked like before. We redesigned it, and you can see how boxy and dark it feels. And this is just few final kind of images of the space and its transformation. We also designed this large furniture piece that was made out of about 1,000 unique pieces and sections. But I will move to the next project. Another project that I was working on is an office for NASA JPL. This project was a collaboration with the City Lab and UCLA. It's an interior shot. This is an interior shot of JPL engineers that work to put rovers on Mars. And we're asked to reconceptualize their interior workspace as well to propose a kind of a relaxation and kind of a new working type space. So this is one project. We did 2 projects for them. This was more of a provocation of what we thought they should be working on inside of their office, but I will not focus on this. I will move to the second project that we did because it was built. So the way we're thinking about the project, we first really have to understand the body and the positions that it kind of is always occupying different spaces, and in that case, work space. Whether we're standing or sitting, we're FaceTiming and interacting with new technologies, FaceTiming, texting, having lunch, and many others. So we catalog all these positions and understood how we really behave while we spent, 8 hours of our time in the office. But we were also interested in the construction methods of architectural chairs whose design was prescribed in the way we use them. So from Marcel Breuer, Corbusier, Mies van der Rohe, and Everest Jennings' wheelchair, we combined all these profiles in one wheel, so you can see that they were rolled all in the inner part of the circle, and you could still and combine together. So we still maintain all 4 profiles of these chairs, but then we wheel them all in a wheel, so we can create all these different positions and variations of how they could be used. And this is the rendering of the proposal. Of course, we were doing a lot of different testings and small-scale studies, but when it came to prototyping, we really had a lot of troubles going through bending the inner tube that was quite difficult for many fabricating shops here who would tell us that it's quite impossible to achieve all the small radiuses. So we moved into the CNC bending that allowed us, let me see if I can play this one, and then finally combine in this one piece. Here it is, Sylvia Levin testing it out, and eventually you can see how the piece then becomes this kind of relaxing space, and the rocking of it always, the body always balances itself in a particular position. And finally, the third project that deals with body objects on the object scale. This is the area that designers don't really tackle much. The idea of the bodily objects has been in a part of fashion, orthopedics, biomedical engineering, but not often thought of being part of architecture and space making. These projects have been developed at UCLA for the past 3 years in the class that I call Prosthetic Seminar, where I'm interested in design research of architectural prosthesis. When I say prosthetics, I don't really mean devices that recover basic human function, but really technological devices that transcend and go beyond human abilities, from enhancing our vision to expanding our field of hearing. These devices also become an interface between our body and its immediate environment, architectural space, or sometimes even virtual space. Here you see a proposal of implants for different functions, from holding a cigarette to whistling to biting your nails, that then could be incorporated in the exterior exoskeleton mask attached to your head. Or this device that is a hearing device that enhances our hearing not only forward but to the back, and completely changes the way we conceive space. The students were also analyzing all the body parts and testing different materials. Here it is, the 3D printed piece, fully wearable, or this project that enhanced our vision to 360 degrees, or artificial skin that allow us to be seen at night and be seen by others. The second year, we focused on connecting the prosthetics and our bodies to architecture. Here you can see the breathing mask that consists of multiple filters that would filter bad air or connect us to the oxygen duct. Or another project that was dealing with the infill between the body and the chair, where the students map different positions to create and discover all the negative spaces between their body and architecture, and propose this adaptable suit that would allow us to work in a more comfortable way, or kind of become a support for different body parts. There was a lot of testing. It's always a lot of testing involved in type of the technology that you're using or materials. Here we're thinking about silicone that has this ability to inflate and deflate, and we can think about this wearable prosthetics as kind of being part of our experience, where here you can clearly see where that could be understood as the pillow that we travel with, or but it becomes a color when it's not used. So there was a series of layers for this piece, where the air could travel through different air channels, and then again the piece became this adaptive place that kind of inflates based on the need. Since we're actually a pretty symmetrical, we have pretty symmetrical bodies, yet our activities do not support the asymmetrical activities, and in a way this is considered as this kind of a piece that would allow for this adoption to create comfort and support. Thank you.